So this is 7-6, part 1. And let's just start. We're just going to graph these because we didn't do a really good job of graphing these yet. So y equals, let's say, 2 cosine of x. All right, well, first, you should have learned in 7.3, one of the questions talked about how you, number 11 in 7.3, you only need 5 points to graph this. Like when we were in parabolas, I told my classes that you needed the vertex, you needed 2 points to the right of this sucker, you mirrored them, and boom, you had your graph for a parabola. Well, with these guys, you need 5 points as well. You need the kind of where the, and this continues like this, it'll loop, we'll do it like that, it'll loop. And it continues doing this pattern up and down, the same exact one. Now, this section right here, notice there's 1, 2, 3. You need those 3 points on the midline. You also need the maximum and you need the minimum. If you have those 5 points, that's good enough for our sketch. Now, what you would do is, let's say I know it's going to complete from 1 all the way up to 1 all the way down. What is that called? How long it takes? That is called the period. So the first thing, if someone asks me to graph this, is I'm going to find the period, and that's going to be my x coordinate that I'm going to plug in. So let's say my period is 2 pi. That will be one of the x's that I'm going to put in my x and y chart. That will be one of my x's. Well, if this is the period, then I know this is half of that, which means that that would be pi. I know that this maximum is going to happen halfway between those two, so it's going to be pi over 2. And I know this is going to be halfway between that and that, which would be 3 pi over 2. And those are my, and this is at 0. So, oops. So my 5 x's that I plug in would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if I got those 5 points, that's good enough, because what do I know this thing's going to do is it's going to repeat itself. It's going to keep doing the same exact pattern. In fact, the next one over, where's the next maximum going to happen? Half a pi from here. So this would happen right here. If you're thinking about this, count by half pi, this would be 1/2 pi. Technically, this would be 2 pi over 2. That's 3 pi over 2. This would be 4 pi over 2. So this next maximum would happen at 5 pi over 2. And I can keep the pattern going. Then it would go back to 0. Then it go down to -1. Then you go up to 0. Then you go up to... You just keep going through that pattern. You could even go backwards using that pattern. Does that kind of make sense to you? Yep, thumbs ups are great. So if someone asked me to do y equals cosine of x, well, that's just the original. If I know that, my first thing I'm going to ask you to do is find the period. Well, the period is still going to be 2 pi. Remember, you take the reciprocal of that, which is just 1, and times it by 2 pi. So 1 times 2 pi is just 2 pi. My amplitude, which is all from 7.3, is a 1. So now I'm going to figure out my x and y chart. Okay, how do I figure out what x's I'm going to put in? Well, just drawing kind of an idea. If this is 2 pi, then we said that this would have to be pi. This would have to be pi over 2. And this would have to be 3 pi over 2. So we've got 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my x's. Now, how the heck do I figure out my y? Well, that's why I asked you to memorize your unit circle, because you're going to use your unit circle to get the outputs. So you're going to use this guy right here. And you'll notice I'm going to highlight some just to help myself out. I'm going to highlight this and I'm going to go, you know what? I know that all the ones in yellow go together. All the ones in green, they go together. All the ones in blue, they match up. In fact, if you look at the order pairs, they're the same. The only thing that's different is the signs. And finally, these guys go together. And let's do red. These guys go together. So when I do this, I'm going to be looking at the X is the radians, the measure of the radian. And then since they tell me sine or cosine, that's going to tell me whether I'm worrying about the X or the Y. So if I look back at the one they're asking me, it's cosine. Well, I know that cosine goes with the X coordinate. Whoops. Cosine is, oh crap. This right here, the X I'm going to put in, is the measure of angle in radians, and the cosine of X, that's the X of the coordinate. So that means if they ask me, they said the first one says the Y equals the cosine of 0. Oops. Y equals the cosine of 0. This is my X. That's what I'm looking at. That's the radians. The cosine of 0 is the X that's associated with that. So that would tell me that X equals 1. So my output would be a 1. If I look at the next one, it's pi over 2. So now I'm doing Y equals the cosine of pi over 2. Well, cosine of pi over 2 is right here. Cosine is the X is 0. So my Y, my output would be 0. So I'd be putting a 0 here. If I looked at pi, the output would be -1. If I looked at 3 pi, the output would be 0. And if I looked at 2 pi, the output would be 1. And so if I looked at the graph of this, it would be 0, 1. And now notice my X and my Y, my tick marks don't mean the same. On my X-axis, I'm counting by ones. On my Y-axis, or I'm sorry, my X-axis, I'm counting by pi over 2s. Every one of these spaces is worth a pi over 2. This is worth a pi over 2. That is your increments, what I'm going up by. My increments here are pi over 2. My increments on my Y are going up by 1. That's totally fine for them not to be the same. So this would be pi. Also, if I was counting, it would be 2 pi over 2, but the 2's would reduce. This would turn into 3 pi over 2. Technically, this next one would be 4 pi over 2, but that would reduce to 2 pi. So those are my x's, and then it says 0, 1. At pi over 2, I go to 0. At pi, it says I go to -1. At 3 pi over 2, it says go back to 0. And then at 2 pi, it says go to here. And if you look, that's 1, 2, 3, 4, 5. Here's half of the top. Here's the other half of a top. And here's the bottom. There's a full period. And then this thing would keep going on with that same kind of pattern. Does that kind of make sense? Thumbs up. So the first thing I'm going to do, if anyone ever asks me to graph these things, I'm going to get the period, because the period is going to let me establish what my x's are that are important. So like if someone asks me for y equals the cosine of 2 pi x. So if I want to establish the period, what we talked about is we would take the reciprocal of that, which would be 1 over 2 pi. We would then times it by 2 pi. And when you do that, this would all cancel out, turn into 1. So my period is 1. So that means that this completes a full up and down by the number 1. What does that mean this number would be? Where is that going to be happening at then?
Pi.
Nope. This is, my period is 1, Orist. The number actually 1, not pi. Where does this take place? The halfway mark, correct? What's halfway to 1?
0.5.
Yep, so 1/2. Where does this maximum happen at? What's half of half?
0.
No, half of half. 1/2 and divided by 2 or times by another 1/2. Half of a half is a 1/4. Where would be the halfway point between 1 and 2, or half and 1? Count by 1/4.
3/4.
1/4, 2/4, so 3/4. So these would be my x's that I would plug in. So my x, if someone asked me to graph this, my x's I'd plug in are 0, 1/4, 1/2, 3/4, and 1. And so what that would look like, guys, I'm just trying to show you how I'm figuring out what my inputs would be. I use my period to figure out which x's I'm going to input in here. And so if I put a 0 in for there, 0 times all of that would turn to 0. So then this would be the cosine of 0. Well, the cosine of 0 is 1. If I go back, cosine of 0, that's the x coordinate, is 1. What if I put a 1/4 in? This would look like this. This is cosine of 2 pi times 1/4. Well, since this is all multiplication, I can reorder that. So I can make this really like a 2 over 1 times 1/4 times pi over 1. And then these reduce. This turns to a 1, that turns to a 2. 1 times 1 is 1 times pi is pi over 1 times 2 times 1 is 2. So this turns into, what I really want is the cosine of pi over 2. Well, the cosine of pi over 2, cosine is 0. So it'd be 0. Do you guys understand what I'm kind of showing you here? So then when I graph this, I would be going up by a 1/4. Your tick marks don't have to be whole numbers. This would be 1/2 or 2/4. This would be 3/4. And this would be 1. And then I haven't changed my amplitude because my amplitude has been 1 every time. Notice that it keeps going, 0, 1, to 0, to here, to here, to back here. And it would look like this. Notice these graphs are going to be very similar to each other. And this would continue, this would continue, following that same pattern. All right, try to see if you can do this. Y equals the sine, notice I changed it, of 1/4 pi x. 4 pi over 4x. What would my period be for that? Anyone? What's my period for that?
8.
Good. Now that means that this sucker completes a full up and down by 8 on the x-axis. What does that mean this point would have to be?
Four.
Perfect. It's half of it. What would this point have to be?
2.
Good. And where would this point have to be? Someone else. It's the halfway point between 4 and 8.
6.
Good. Now, why are those important? Because those are going to be my inputs that I'm going to put in here. The first one is 0. I'm going to put in for x, then 2, then 4, then 6, and then 8. And what I'm going to do, thinking about that gets me my inputs that I'm going to want to use. It gets me my 5 most important points to get this graph started. So I'm going to go, okay, if I put a 0 in for x, what's 0 times pi over 4 is 0. So I'm looking for sine of 0. Now we've changed this. Sine is the y. So 0 would be my output. So I'd put a 0 here. Remember, it's going to be the same order pairs because you're still using just a little different. Maybe your x's are different, but your outputs are going to be kind of similar. What if I put a 2 in here? Okay, what does that mean? That means that this is going to be pi over 4 times 2, right? We know how to multiply fractions. This is 2 pi over 4. Reduce these suckers. It turns into pi over 2. So now I'm looking for the sine of pi over 2. Well, sine of pi over 2. Sine is the y. So for this one, the sine of pi over 2 is 1. So my output for that would be 1. Next one, if I did the sine of pi over 4, and then I put a 4 in for x, do this turns into 4 pi over 4, or just pi. I should know my unit circle. The sine of pi would be the y coordinate of that, which would be 0. If I did the next one, this would be -1. And if I did this one, it would be back to 0. And then I would graph this thing. My amplitude is 1, by the way. So I'd go, this would be 1, this would be 1, and then 2, 4, 6, 8. Remember, I'm the person who establishes how I'm going to count. So I go 0, 0, 2, 1, 4, 0, 6, -1, and there we go. Boom. And then, like I said, it's going to continue. Questions on that? Does it make sense how I am deciding, like how I'm using the period to pick these x's? And then I'm just plugging them in and seeing what the outputs are. The only thing that can change is maybe I put a 2 here. Now what's that going to change? Well, that's going to make this right here, when this became a 1, 1 times 2 is going to be a 2. So instead of going just to 1, it's going to go up to 2, which is what we talked about. It's just going to change the amplitude of it. So it's just going to be taller peaks and valleys. Do we understand that so far? Questions?